So this is the last one on setting up and solving differential equations. This time we're talking about Newton's law of cooling, which is a bit of a classic. It's something like Mr. Speranza doesn't like hot coffee. He only drinks it at 56 degrees. It starts off at 79 degrees. The ambient temperature in the room is 14 degrees. When can Mr. Speranza drink his coffee? That's the question. Anything that cools follows Newton's law of cooling. So Newton's law of cooling says that the change in the temperature of the coffee, they say the body here, with respect to time, is proportional to the temperature of the body minus the temperature of the surroundings, or the ambient temperature. And then, of course, because it's proportional, we can write it as the change in the temperature with respect to time is equal to K times the temperature of the body minus the temperature of the surroundings. All right, so there's our sort of jump off point, and from there we can solve all of the coffee, bread, fire, whatever it is. Something's getting cooler, probably not fire. All right. Question is, a loaf of bread at temperature 20 degrees is placed in a freezer whose temperature is a constant -15 degrees. If it takes 18 minutes for the temperature of the bread to drop to 8 degrees Celsius, how much longer to the nearest minute will it take for the bread to reach 0 degrees? All right, so we know how long it takes to get to 8 degrees. We need to find 0. Newton's law of cooling applies. So we can say that the change in time the change in temperature with respect to time is equal to K T minus Ts, where T is the temperature of the surroundings, which is -15. So we get down to here. Now, important to note that the initial formula is -Ts. So if the temperature is -15, then it's minus 15. All right, from here, inverting the equation, because of that T there and there, integrate, and we get something like this: 1 on K log base E A T plus 15. And that C value, we have talked about that in a few videos. If you're still scratching your head, come and see me. All right, substitute T equals 0 and T equals 20 into the equation. Y 0 and 20, there's our initial condition there. A loaf of bread at temperature 20 degrees, and that's at time 0. So there's our initial condition. So when time equals 0, T equals 20, that's going to put our 0 out the front, which we know makes our life easier because 35A is going to be equal to 1. So A is equal to 1 on 35. If we put that back into this equation here, we can now find 1 on K by subbing in some other condition, which we have. 18 minutes to drop to 8 degrees. So that's going to allow us to find this this K value here. Okay, so 1 on K equals -42.872, and our equation is now this. Now that we've got an equation, I don't even know what the question was. What was it? How much longer to the nearest minute will it take for the bread to reach 0 degrees? Okay, so we definitely have an equation now. So time, temperature, we want to be 0 degrees. So let's sub 0 degrees into here. And we get 36.325. But you need to be careful because it says after 18 minutes, the temperature of the bread drops to 8 degrees. How much longer to the nearest minute? So I've subbed it in, I've gotten 36, but the answer to how much longer is 36.325 minus 18, which is 18. Okay, so that is Newton's law of cooling. It definitely comes up quite a bit. That's how it's done.